Hello everyone, my name is KatieMarie Magnone. I'm a second year PhD student in Dr. Yezierski's research group in the Department of Chemistry and Biochemistry, and today I'm going to be talking to you about some of the ways that we had to modify our data collection protocols for in-classroom data collection for the upcoming academic year due to distance learning. So first I will give a little bit of context of what the VISCHEM project is. This is a multi-year project that aims at studying how teachers' use of molecular level representations in their classrooms affect student learning and understanding of molecular level phenomenon. This takes place over a sequence of activities that we refer to as the VISCHEM approach, and the project itself consists of a professional development program followed up by in-classroom data collection. It's this in-classroom data collection portion that I'll be talking to you about today. In order to understand why we made some of the changes that we had to make, you must first understand what the VISCHEM approach looks like from the student perspective. The first component is that students will engage with some macro scale phenomenon, such as viewing a video or performing an experiment or viewing a demonstration. And this will be followed by the students drawing a storyboard of what they believe this process looks like at the molecular level. And this storyboard consists of drawn sections and accompanied text to describe what is happening in their drawings. Next, the students will view a dynamic molecular level visualization that has been developed to specifically highlight the chemical intricacies of these various processes. And they can watch these videos multiple times, slow them down, pause them, etc., in order to be able to see everything that's going on. And then finally, the students will either revise or recreate their storyboards to amend them with new information that they may have gleaned from watching the VISCHEM animations. While the larger VISCHEM project is driven by multiple research questions, this particular component of it is driven by one specific research question, and that is, to what extent and in what ways do student ideas about molecular level behavior underpinning chemical and physical phenomena change when teachers use the VISCHEM approach? And to this end, the way that we intend to address this research question is by analyzing the student storyboards that we collect to look for changes in the features or processes that students choose to depict in their storyboards and in their descriptions as a result of the VISCHEM approach. So comparing that pre to the post information that we get in their initial and the revised storyboards. As far as how we are going to collect these storyboards, our original data collection plan pre-COVID-19 shutdowns had to be heavily modified because we can no longer go into classrooms and have teachers go into classrooms to collect the physical objects. So where in a face-to-face learning environment, the students would have drawn on pre-printed templates of those storyboards, which contain the boxes for the drawings, the lines to prompt them to include their explanation, as well as the molecular keys. The teachers would then collect and scan those storyboards at two different points after they had completed their initial storyboard, before they viewed the animation, and then after they viewed the animation, once they had revised it, the teachers would collect and scan those storyboards and upload them to a research drive. But now in the era of remote data collection, what we have students do is to draw these molecular level phenomenon on a blank sheet of paper, take a picture of those drawings and insert it into a graphic of the storyboard template that we've created in Word for the teachers to use for this. And then those storyboards get submitted, in this case through Google Classroom. The teacher will then take those digital files and upload them to the research drive. While it might seem superfluous to have students hand draw a graphic and then insert it into a digital template, we did have specific reasons for doing so. First, we wanted to avoid the possibility that students would create a reference bank of molecular images that they would simply copy and paste where they thought was appropriate into these images. We wanted to retain their hand-drawn features as those would most indicate what they deemed important as features. Specifically, we can gain insight into their knowledge and what they wish to convey about a topic based on how they choose to represent certain things, such as how they choose to represent species such as polyatomic ions. In these cases, these two students have different choices that they made about how they were going to represent these polyatomic ions, and there may be information that we can glean from this. In coming up with how we were going to revise our data collection plan, there were a couple of things that were at the forefront of our mind. The first is that we wanted to reduce the workload for teachers to collect and submit the data to us. This takes the form of working with teachers who are in remote learning environments and using the tools that they were already using, such as Google Meets or Canvas, for capturing and collecting the data from them. The second of which is, as much as possible, we are going to provide those digital templates ready for the students to insert their graphics and text responses for the teachers to then return to us. Finally, I would like to acknowledge the people and foundations that supported this work and project, and to thank you all for your time and hope that you're all doing well.